Hi class, welcome to 10.6 day 1. In this lesson we're really interpreting graphs of exponential functions. So it's a really great skill to look at a graph, analyze what it's saying, and drawing different conclusions from it. So that's what we're going to be practicing in this lesson. So here's our first one. The pesticide DDT was widely used in the United States until its ban in 1972. So what a pesticide is it's a chemical that they put in crops and in the ground to repel different insects and different things that want to eat our crops. So this DDT was banned in 1972 because it was a toxic to a wide range of animals and aquatic life, and it's also suspected to cause cancer in humans. So they didn't want to use this anymore for a pesticide. The half-life of DDT can be 15 or more years. So the half-life is the amount of time it takes for half of the amount of substance to decay. So our world has a natural way of decomposing different substances. When you throw a banana peel on the ground, in about a week that banana peel is gone. It's biodegradable. This pesticide, it decays, but it takes a lot longer than a banana peel, obviously. It takes 15 or more years for half of that pesticide to decay. So scientists and environmentalists worry about this, that there's hazardous materials that continue to be dangerous for many years after its ban or after its disposal. So let's look here. For this example, we will set the half-life of pesticide of DDT to be 15 years. So if we look at our x-axis here, each interval is 15 years. So here is 30 years, because when x is 1, it's 15, 2 is 30, 3 is 45, 4 is 60, and we can keep on going that way. The y-axis is each interval of grams of DDT remaining. So 100 grams, 90 grams, 80 grams, 70 grams of DDT. So after 60 years, estimate how many grams of DDT remain. Well, here's 15, 30, 45, 60. It's that y value. How many grams? What is the y value at the x value of 60 years? Well, if we look at that point right there, it looks like it's right at about the halfway point, maybe just above the halfway point, so it's in between 0 and 10. I would say it's approximately 6. If you had 6 on a test, I would give you the right answer. However, we could not even approximate, but we could find out for sure. If there's 100 grams in the soil, after 15 years, half of it is gone, and that point is 50. So then after 15 more years, that 50 grams turns into 25 grams. And after 15 more years, that 25 grams is 12.5 grams. So then after 15 more years, which is 60 years later, half of 12.5 is 6.25. So that is the exact answer for what we're looking for. After 6 years, there's 6.25 grams of DDT left. So that's a little bit what we're looking at with this lesson. Let's now take a look at the next one. Exponential growth with this one. One of the most common examples of exponential growth deals with bacteria. Bacteria can multiply at a very fast and alarming rate when each bacteria splits into 2 new cells. Thus, it's doubling. So for example, if we started off with 1 bacteria, and if it doubles every hour, after 1 hour there's 2 bacteria, then there's 4, then there's 8, then there's 16, then there's 32. After the end of 1 day, there's over 16 million bacteria. That grows at a very alarming rate, does it not? So what we want to know, after 14 years, estimate the number of bacteria cells that there are. So again, as I said, after 1 hour, there's 2, after 2, 4, 3, 8, 4, 16, 5, 32, and you really get it by doing these. 2 to the 5th is 32, 2 to the 6th is 64, all that. So if we're just looking at the graph right now, after 14 hours, here the x value is 14, so estimate the y value. Well, it's that point right there. How many cells are there? I would say it's in between 16,000 and 17,000. If you want to say it's approximately 16,500 cells, I would give you the right answer on a test. All we're doing is just interpreting the graph. However, once again, if we wanted to find out the exact number, after 14 hours, notice our pattern, 2 2 to the first after 1 hour, 2 to the second after 2 hours, 2 to the third after 3 hours. After 14 hours, it's 2 raised to the 14th power. So you can put that into your graphing calculator. What is 2 raised to the 14th? It is 16,384 cells. Exponential growth and exponential are very interesting because they grow at a very alarming rate. So it's stuff that definitely impacts our society. Let me know if you have any questions on that when you get to class tomorrow.